So let's walk through one of these guys here. Discuss and graph the equation r equals 6 over 2 minus cosine theta. So we know it's clearly polar because it's an r. All our polar things are going to be r comma thetas. So if we can plug in some thetas, we can find r's. Basically, you could sit there and you could just make up a bunch of values here for theta, and if you went from 0 to 360 degrees, it would graph itself. But that's a whole lot of stuff to plug in, so we want to try and get some major points by hand and fill in everything else. So let's go through our steps. First step, solve the equation so it's 1 plus or minus whatever's on the bottom. This is the guy you want to turn to a 1, not anything else. So we're going to divide everything by 2. To make this guy down here 1. So this is what we're really going to be working with. 3 over 1 minus 1/2 cosine theta. We're done there. Second step, find the eccentricity. Here's our equation. Eccentricity comes from that number right in front of the sine or the cosine. Eccentricity is 1/2. Always take the positive with it. Find the p. Well, E times p always equals this thing up top. So I know E is 1/2, so I know p has to be 6. We're done there. Determine which axis it's on. It's a cosine, so it's either going to be perpendicular to the x-axis in a positive direction or a negative direction. Determine the shape. So we go to eccentricity, we see 1/2. So that means C over A is less than 1. We remember what we said about all these. Any eccentricity less than 1 gives us an ellipse. So I'm going to write down it's an ellipse. Now, plug in 0, pi, pi over 2, and 3 pi over 2. So far I haven't done anything too difficult. We know anything polar is an r comma theta. So what I'm going to do is go plug in a 0. I'm going to plug in a pi. I'm going to plug in a pi over 2. And I'm going to plug in a 3 pi over 2. Okay, this will be enough information to get me some points. You could use this guy right here to plug these in. It's got the 1/2 though, so some of the calculations may be a little bit more difficult. I'm going to go back to the original again. So if I go plug in a 0, so I'm going to come back up here and basically just do 4 different problems plugging these in. So if I let this theta be a 0, cosine of 0 is just a 1. So this is 6 minus 2 over 1. We get a 6 there. Okay. Next, I'm going to go plug in a pi. Cosine of pi is -1. So this is 6 over 2 minus 1. So 6 over 3 is 2. Next, I'm going to go plug in a pi over 2. Cosine of pi over 2 is 0. That means that entire thing goes away, which is kind of nice. So it's just 6 over 2 is 3. And the same thing is going to happen at 3 pi over 2. Cosine's still a 0, so this guy also turns out as 3. Okay, I'm going to pause it here and grab these points over to the next slide so we can actually graph these. So let's get all these points graphed here. We're going 6, so it's going to be a little off our grid here in the direction of 0. We're going 3 in the direction of pi over 2. We're going 2 in the direction of pi. And we're going 3 in the direction of 3 pi over 2. Now, you're going to see that that's not perfectly spaced, meaning this distance is a lot bigger than this distance right here. So what we have is a bunch of vertices. So if we want to find where the center is, it's going to be right here. Okay, these two guys on the x-axis will give us our vertices. Center is going to be halfway in between them. So that means that we know this is an ellipse because we said eccentricity was less than 1. Normally when we do ellipses, we come out from the center and we come up from the center like this. Okay, that's not going to be the case in polar now. So what I want you to do is just pick some point a little bit bigger than these guys here and try and get it to be as nice and elliptical as possible. So we're not going to worry so much about this distance this way and this distance this way, but what I want to see is that you've plugged in all the points and you're able to get those 4 things right there. Okay, so it's going to be off a little bit. One thing we haven't talked about with this guy is that the P came out to be 6. What that means by definition of this stuff we talked about earlier directrix is a distance P from the pole. So when we said P equals 6, it was a cosine. So we said it either had to be, it's going to hit perpendicular on the cosine axis. It is a 1 minus 1/2 here, so that tells us it's going to come back the other way. Okay, so that's going to give us our directrix at 6 back this way, perpendicular to the x-axis. Now in this case we don't really need to graph it because it's an ellipse and we haven't used them before, so we're not going to use them now, but just so you know that that's where that guy comes in. Okay, we're going to bring this over to part 3 and do one more example. So tonight's lesson is a little bit longer here, but it's good to take the time and make sure you're able to do these.